When I am looking at these transformations of parabolas, I get back to where the first thing I think about is what does, and I'm gonna erase this in just a minute, but what does the regular y equals x squared parabola look like? Well, if I'm looking at the regular y equals x squared parabola, I know that the vertex of that one, and apparently I did not line this up very well, the vertex of that parabola is at the origin, is at 0, 0. And let me make this line a bit thicker for my next axis. Okay, that may be a little bit too thick, but hey, we'll go with it. So I know that if I'm talking about the basic parabola y equals x squared, at 0, y equals 0 squared, so it's 0. At 1, y equals 1 squared, so I'd go up to 1, and the same thing with negative 1. At 2, y equals 2 squared, so I'd go up to 4, so negative 2 I'd also go up to 4, because negative 2 times itself is 4. So this is the basic y equals x squared parabola that I can't draw very well on this, and I apologize. Well, in this case, they said, hey, take this parabola, translate it 4 units to the right. So instead of being here, I'm going to have to move the vertex 1, 2, 3, 4 units to the right. Now it has the same shape, because it just said translate it, so just move it, but don't change the shape. So when I graph this one, and let me now erase some of those original things. So when I graph this one, it has the same shape, which means when I move 1 unit to the left or to the right, I go 1 unit up on y. 2 units go up 4, and then this is this parabola. And again, I can't draw these very well. I'm not going to take time to put the full scale in just because of the time on the video. Well, let's think about it. That means that an x value of 4 has the same y value as the original x value of 0 did. X value of 5 has the original the y value of what the original 1 did. So what happens is I have to take the x that is here, which is 4, and subtract 4 from it to get back to 0 before I square it to still get a y of 0. An x value of 5, I have to subtract 4 from it to get you back to 1, and then square it to get up to 1. So when I shift to the right, I have to shift this, x minus 4 squared. I'm going to go ahead and do 2 on a video, so translated down 5 units. Well, again, it didn't talk about changing the shape at all, so this thing's still going to be move over 1 from the vertex and shift your y by 1. Move over 2 and shift your y by 4. The difference is my vertex has shifted down 4 units, but it has the same shape. 1 away on x goes up 1 on y. 2 away from the vertex on x goes up 4 on y. And it looks like I just translated it down 4 units instead of 5, so let me fix that really quickly. So 5 units over 1, up 1, over 2, up 4, again because 2 squared is 4. So that's what this is going to look like. Again, I'm not taking time on this video to draw in my scale, but you should have your scale in there. So the thing that has happened is my y has shifted. So my x hasn't shifted at all, but my y, in order to find the y value of the new one, the new y, it's 5 less than the y value of the old one. So to get back up to the original y equals x squared, I would have to add 5 to this y value. Now we don't leave it this way. We subtract 5 from both sides to get the y by itself. So y equals x squared minus